And that way we can post it for other students in the classroom. Okay, there we go. Okay, so the topic for today is drawing linear equations given 2 points and from the equation Ax plus by equals C. So I'm going to just check, yeah, make sure there's no one in the waiting room. So everyone's on. Close that one down. Okay, and I'm going to just copy a grid over from the previous lesson that we did last day. So Control C here. Okay, there we go. So there's a grid for us here. Now I'm going to draw 2 points on the graph, and then we're going to write the equation from it. And this actually is going to be fairly sort of an easier one to do, but just to start us off here. And easier in that you're going to have a nice clean y-intercept. So I'll put it right here. And I'm going to put a point, let's say, right here. So this would be given, given the points, what would that be? 0, 3, and 1, 2, 3. And that's in the 4th quadrant. So 1, 2, 3, mid, -3. Okay. And so what we're going to try to do is can we write the equation for this line given those points? Now, what might be helpful here is you think, well, if you draw a line between the two of them. Hey, Caitlin. So draw a line here. And then get rid of the ruler. So you've got these 2 points. Could you write an equation for that line? So remember, the equations take the form y equals mx plus b, where b is the y-intercept, and m is the slope of the line we're looking at. Now, if we're given the picture, it's actually easier just to go off the graph than to use any kind of formulas. But we should get used to using formulas because sometimes we don't have a graph to work with. But let's just use the graph and see if we can agree with this. So I would look for the y-intercept first. And the y-intercept is anywhere where the graph crosses the y-axis. And what you'll notice if you're given a point, by the way, because clearly this would be the y-intercept right there. If you look at the coordinates of that point, what you'll notice is that at the y-intercept, the x value always has to be 0. So that's just a little bit of a clue for you. If you're given a bunch of points, you're kind of like, well, I wonder where the y-intercept is. Well, anywhere where the x is 0, that would have to be a y-intercept. Okay, so I know the y-intercept is 3, so I guess I could say y is equal to mx plus 3. So I know that's true. And then I have to figure out the slope here. Now there is a formula for slope, which if you use it properly, you'll always get the plus and minus right. But if you're using the graph, you can easily make a mistake of making it positive when it should be negative. So what I would think of maybe is if you were standing here, let's say that's Jin right there, there he is right there, and you're walking that way, would Jin be going up or down on that line? Well, if he walks to the right, he's going to be going downhill on that. So a line that goes down like this has a negative slope. So our slope has to be negative. We talked about this in a previous video. And so I would expect to see a negative in front of whatever number goes there. And then basically all you have to do is find the rise. So slope is rise over run, which in this case is a negative rise. So it's actually going downwards. And so what I would do is I would just find the distance you went down. So I'm going to go down here. So I went down that far, and then I went over this far. Okay, so that's 3 there. Okay, and then from this would be 1, 2, 3, 4, 5, 6. So this here would be 6, but because it's going downwards, let's say negative 6 here. So basically, I go down -6, but I run 2. So if I divide those numbers out, I get -6 divided by 2, which is -3. So I now know the equation is y is equal to -3, that's my m value, x plus a y-intercept of +3. Okay? So I'm going to show you how to do this question without using a graph here. So this actually is a little bit more algebra here. But a lot of the questions you're going to get won't have a graph for you. So you have to kind of see how would you do this without that. So let's find our slope first, actually. So what I would do first of all is, let's say you're given these 2 points. So you're given the point 0, 3, and the other point was 3, -3. So it's the exact same question, but imagine you didn't have a graph to do this. And so they said, given this, write the equation of the line. So that is the line that would go through these 2 points here. So once again, I would start off with your basic equation, y equals mx plus b. Okay. And I can kind of cheat here a little bit, because remember that little trick I told you guys? If that's a 0 for the starting value, it has to be a y-intercept. So I automatically know the b value is 3 here. Okay. But there could be questions where you don't know that. Maybe it's not 0, 3, maybe it's 2, 3 or something like that. And we can give you a different question in a second. So let's find the slope now, but without using a graph here. So m is the slope. So m, the slope is rise over run, which is y2 minus y1 all over x2 minus x1. And so that's the equation for the slope of a line. So what I do now is I basically just make one of the points 0.1, and I make the other point 0.2. So since this is my first point here, I'm going to make this x1, y1. And I'll make this x2, y2. And as I said in another video where we did this formula, it doesn't matter really which one you make 0.1 and 0.2, as long as you're consistent. So that if you were to make this x2, this would have to be y2 then. And then the other point would be x1, y1. So we're gonna go with our original statement here. So what I do is I take x2. So x2 would be this number here. So that's 3 minus 0. Okay. And I take y2, which is -3. And now I minus 3. So I'm going to get 3 over top of -6. -3 minus 3 is -6. And if I divide those two numbers, I get negative, oh, sorry, whoopsie. That would be a blunder there. Let's try that one more time. y2, -3 minus y1 minus 3. I had to invert it. And then now for my x values, I take x2 and I minus my x1, which is 0. So I get -6, sorry, over +3, which is -2. So y would equal -2x plus 3. And no one called out above. I saw my blunder up here, which is why I was getting my numbers all messed up. I put a 2 down there. Should have been a 3. So I'm going to just have another big drink of coffee here, because apparently my brain is not firing on all cylinders right now. So we can see this equation now actually is the same as that equation. So here we go. So let's try one more question of that type. And let's call this example 2. So let's say there's 2 points. There's a point, so a line passes through, let's say -3, 1, and let's say 2, 4. Okay, so it passes through those 2 points. And we want you to find the equation of the line. Now, just to write down some steps for you here, just to give you some suggestions, like what you might want to do first. I would look for any what we call give me's first. So a give me would be if I told you the x value was 0 for one of the points, then you would know the y-intercept. So unfortunately, in this question, I haven't done that. I haven't given you sort of an easy one here. So I think the steps would be to find the slope first, which is kind of what we just did up there. So find your slope. Just don't make the mistake I just made, which was I took the x values over the y values. It has to be y over x. So find your slope first. That does take a bit of work. And then I would find the y-intercept, unless it's obvious where it is. So find the y-intercept. And then once you have those 2 things, you write your equation. So why don't you just take a minute, see if you can find out what the slope is. See if you can do it on your own without me showing you. And once again, if you're not sure, that's this equation here. So make one of your points 0.1 and one of them 0.2, and you guys find the slope. And I will keep drinking coffee. Okay, so if we find the slope, we would take y2 minus y1. So 4 minus 1 is 3. So that'd be that number, the rise. And then we do x2 minus -3. So really 2 plus 3, which should give us our 5 value here. Okay. In fact, if you were to sketch this really quickly here, 1, 2, 3, and then 1, and then 1, 2, 1, 2, 3, 4. It's kind of hard to see from the drawing I just did there, but it does look like a positive slope. I think it's going upwards. Okay, so that would be a positive value. So we've just did find our slopes. We did that. That's probably the a pretty good chunk of work here. And now you're going to try to find your y-intercept. So our y-intercept is, once again, from this diagram. It's really hard to read that. I don't know if I've drawn that very accurately, but it would be somewhere in there. So what I know is the y-intercept would have to be a positive number, whatever it is. It's going to go through the positive part of the y-axis. So what I would do now is I would write out your equation with the slope, so 3/5 x, and now I go plus b. So b is the number you want to find here. Now this can be a bit intimidating at this point because you've got these 3 letters. You've got this y, an x, and a b. And it really doesn't matter whether you're really, a really strong math student or, a student who really struggles at math. Nobody can solve this equation unless you know 2 of the values to solve for here. So what we're trying to solve for is b. We're trying to get that value b there. And so unless you knew what x and y were, there's no way you could solve that. It would be impossible. But you actually do know what x and y are because you know the line passes through this point and this point. So if I plug in those values into the equation, it should work for me. Now, it doesn't matter which point you pick, as long as you do the math right, you should get it right. And in fact, I'll do it both ways. But what I would encourage you to do is pick the points that have the least number of negative signs, because that's always the tricky part for students, is all the multiple negative numbers. So I'm going to do the question first using this number, okay? But I'll also show you this. It gives us the same value here, okay? So I'm going to plug those numbers in to begin with. So I'm going to, in brackets here, I'm going to say, I'm going to plug in 2, 4. And I'm going to plug it into the equation above. And what I mean by plug it in, I'm going to substitute the letters for those numbers. So remember, the first number is x, and the second number is y. So when I plug that number into that equation, my y value is going to become 4. It's going to equal 3/5 times the x value of 2 plus b. So before I solve that, I just want to just go over that again. I took one of the points that was on the line that has the slope 3/5, and I plugged it into the equation. So my x value was 2, so that went for x. That's x right there. And my y value was 4, and I plugged that in for my y value there. Okay, so let's tidy this thing up a little bit. So this 2 I just put in. Let's put it over 1 for now. Let's just say it's over 1, because that's what 2 is. And let's just tidy our equation up a little bit. So we're going to get 4 equals 3 times 2 is 6/5 plus b. Okay. Remember, b is the y-intercept here. So what do we do next here? Well, I'm going to use that little technique we talked about in the previous chapter, how we can get rid of fractions here. Otherwise, I'm going to have to bring the 6/5 over and subtract 6/5, which, you know, if you're comfortable working with fractions, that's fine. But I'm going to multiply by the LCD here. So I'm going to take this equation, and I'm going to times everything by the LCD. So my lowest common denominator is 5 here, so I'm going to times everything by 5. So 5 times 4, times that by 5 is 20. So timesing that by 5. And now 5 times 6/5, well, the 5s would cancel, which is why you're doing that, which gives us 6. Or you could say it gives you 30/5, which also gives us 6. And now plus 5b. So if I bring the 6 over, that's going to be, sorry, I should show that, sorry. So I'm going to minus 6 from both sides. So that gives me 14 equals 5b. And now I divide both sides by 5, which gives me a pretty ugly intercept here of b equals 14/5. Okay. Now, if you wanted to work with fractions, just to show you that it would have worked out the same way, you could bring the 6/5 over. But now you got to make the 4 to something over 5, so that would be 20/5 minus 6/5 equals b. So b is equal to 14/5. So you could definitely do it. You could definitely do it that way. Okay. So I actually know my y-intercept now, so I could use that. But I did say it didn't matter which number you plugged in here. So I'm going to use the other point just to prove this, -3, 1. So now my y value is 1 equals 3/5 x, so times -3 plus the b value. So 1 is equal to, because we're 1, -9/5 plus b. And now I would times everything by 5 again to get rid of the 5 as the denominator. So that's going to give me 5 equals -9 plus 5b. So I add 9 to both sides. So I get 14 again equals 5b. So b is equal to 14/5. So it didn't really matter which point I picked. It gives me the same answer. I would just pick 1, and the one that has the least number of negative signs. But if you have time to check, it's always nice to know you did the right thing. You should get the same answer. So the equation then is y is equal to 14/5x. Well, sorry, y is equal to the slope, sorry, was 6/5 3/5. Where's it? 3/5. So slope is 3/5 x plus a y-intercept of 14/5. So if you imagine this graph, it doesn't go through any nice points. It has a pretty horrible slope. So trying to draw this, like just, I was going to scroll it for a second here. Trying to draw this like that kind of picture, it'd be really hard for you to find the y-intercept. In fact, probably almost impossible, I would think, to get the y-intercept being 14/5 here. So this is where we use algebra, which we did quite a bit of last chapter, and you guys did quite well on that, where we used algebra to find certain values here. Okay, so I'm going to do one more type of question here, and this comes back to, first of all, how do you even know that you're dealing with a line? Like we drew a bunch of pictures on the Desmos program there. We drew circles and parabolas and then some lines and stuff. Let's say you have y equals 2x plus 3. And someone said to you, well, what shape is that, first of all? And you might say, well, it's a line, because that's what we've been talking about. But how do you know it's a line? Like, what if I wrote this? 2x squared plus 3. So what is it about these two things that produces different shapes here? Well, the one thing you want to look for is the powers on the two variables. Now, normally when we don't write a power in, we assume it to be a 1. So this is y to the 1, and this is x to the 1. Now here, this is y to the 1, but notice it's x to the 2 here. So if you graph these two things on Desmos, you'll get two very different looking pictures, actually. The first one is a line. This is linear. And this one actually turns out to be what's called quadratic. But that's more of a grade 10/11 thing you'll learn about. And so we don't do any quadratics in Math 9, so you don't have to worry about that. But how do you know it's linear? Well, you know it's linear if the power on the y is a 1 and the power on the x is a 1 also. If that's true, then it has to produce a straight line. It'll always produce a straight line. So all the questions you've been working on right now, you might not have thought about that. You might not have thought, what is the power? But any of the questions you've done, if you go back, like the one we just did, that's a 1 right there, and that's a 1 right there. And so because of that, that'll always produce a straight line. So let's take a look at an equation that's written a slightly different way. And you guys think about whether the powers are 1s here or not. So let's say you had 3x plus 2y, and you were told that equals 6. Okay. And someone said, well, I want you to graph that picture. I want you to draw a picture of that thing. So let's get a graph here. If I can Control V. Work. There we go. So someone says to you, I want you to draw that picture. What shape would you get, first of all? Well, you actually would get a line. We know the power on the x is a 1 and the power on the y is a 1. The problem is that that question is not written in the way you're used to seeing it. It's not written in what we call the slope-intercept method. So the slope-intercept method is y equals 2x. Sorry, y is equal to mx plus b. So that's what we refer to as slope-intercept. So if you did the homework from the previous sections, you know by now that b is the y-intercept, and you now know the slope is the m value. So we refer to this as the slope-intercept form because it allows anybody, students, teachers, people from different countries, to draw these shapes really quickly. So you just plug in your y-intercept and you plug in your slope. So one thing you could do to this equation, you could rearrange it and make it look like that. You can make it look like the slope-intercept form. But I want to show you a different technique that is much quicker for you. And it involves two things. It involves you understanding that this actually is a line, which we just talked about. And it also involves understanding the idea of what we call intercepts. So we did y-intercepts. So here's the first thing. So is this a line, first of all? If it's a line, the x value has to have a power of 1, and the y value has to have a power of 1. So this will produce a straight line. The second part of the understanding here is if it's a line, it's a straight line, and I give you 2 points, and I say these 2 points are on a line. So I just draw a grid here, and I say this point and this point are on a line. Well, there's really only one shape you can draw. You'd have to draw a line that goes through those 2 points. So if you can find 2 points on this graph, then you have a straight line, right? So let's find 2 points on the line. And what we're going to use is what's called the intercept method. Now this method is a little bit maybe abstract the first time you hear it, so I'm going to do it a couple times just to go over it, because it is a bit strange to think about. And I'm just going to plot a point on the grid right now. It's not saying it's on this line, but I want you to think about that point right there, the one I'm drawing right now. And I want you to just on your notebook paper, I want you to write down the coordinates of that point. And I want you to do it for this point too. So write down the coordinates of that point, and then when you've done that, write down the coordinates of this point. Okay. Well, if I scale my axis here, that's a 1, 2, 3, 4, 5, 6. And this would be -1, -2, -3. Right? And my x-axis here, that would be a 0 there. So this first point would be at 0, 6. This next point would be at 0, 3. And the next point would be at 0, -3. Right? And those would all be considered points that go through the y-axis. So those would all be y-intercepts of the graph. And now let's take a look at the points along the x-axis. Let's take a look at this point here, maybe this point over here. So why don't you guys write down the coordinates of those 3 points? Well, the first one, that's -1, -2, -3, -4. And that was -1. And this would be 1, 2, 3, 4, 5. So that'd be 5 right there. So these actually would all be points that are on the x-axis. So they would be x-intercepts, places where the graph crosses the x-axis. And this would be -4, 0, -1, 0, and 5, 0. And so if you notice that the x-intercepts, they all have something in common, and the y-intercepts also have something in common. So when I use the intercept method, what I do is I look, first of all, for my x-intercepts. And what I have to realize here is that if the graph crosses the x-axis, it crosses here, here, or here, that's the x-axis, it has to have a y value of 0, which means in order to find an x-intercept, I just set my y values to 0. And if I want to find a y-intercept, notice the y-intercepts now, they are here, here, and here. And the y-intercepts, they all have x values that are 0. So I would set my x values to 0. So let's see how this would work in this question. So I have to erase all these points now. So hopefully that kind of made sense. So I erase all these points, get rid of all that junk. And so once again, teaching the theory takes a bit of time there to explain this to you. But watch how quick this is once you understand the theory. Let's see how quick this is. So I'm going to find my x-intercepts for the equation here. So once again, to find my x-intercepts, I set the y values to 0. So I'm going to have 3x plus 2 times 0 equals 6. So notice that I set my y value to 0. So I get 3x plus, well, 0, I guess, because 2 times 0 is 0, so just 3x equals 6. And now I divide by 3. So I get x equals 2. Not sure what that was about. So 2. So I go over 2, and that's my x-intercept at 2. Okay, so now I find my y-intercept. And to find my y-intercept, I set my x values to 0 now. So 3 times 0 plus 2y equals 6. So really 2y equals 6. So really y is equal to 2, divided by 2, sorry, which would be 3. So I have an x-intercept and I have a y-intercept, which is really all I need because a line has to go through these 2 points. So now I just take a straight edge or a ruler, and I line up my straight edge with those 2 points as best I can. Probably a little bit off here. I'm a little bit off, but you can get the idea here. And there's my line. Okay, so this method of finding x and y intercepts and then just drawing the line between the 2 points is a really fast method to draw the shape of a linear function and go from there. But let's just sort of shrink this down for a second. I'm just going to show you on the side here because some of you may say, well, you know, it looks like voodoo to me. Not too happy with that. Let's say I wanted to turn this equation into the standard formula. Y equals mx plus b. You're like, I'm more comfortable with that. That's what I understand. That's what I want to work with. Well, you could bring over the 3x. So let's subtract 3x's from both sides. So I'd be left with a 2y here. Now, unfortunately, I can't subtract 6 and 3 because one of them has an x with it. So this would be minus 3x plus 6. And now I have to divide every term by 2. So now I divide this by 2. I divide this by 2, and I divide this by 2. And so I get y equals negative 3 over 2x plus 3. Now, this means this should be the y-intercept, which it was. We determined that already. Our graph shows that. And we should be going down 3. Use that orangey color. Down 3 over 2. So this is a nice way to verify that, I guess, if you want to. But I think you'll find this method we just did here much faster once it kind of clicks for you. Just make them zeros. And another big thing is when we graph in grade 11 and 12, finding x-intercepts and y-intercepts is a really important skill. So I would encourage you to try this this method here. So today, just to wrap up here, we've done a couple of different questions. We've done ones that find the equation of the line given 2 points. So find equation of the line given 2 points. And now we've sort of solved for the equation in the form ax plus by equals c. And the homework on this will be page 132, number 9, all. And done those ones already. I'm going to write a bit more homework for you on the Google Classroom, but just to get you started for right now, if you want to work on this, page 137, numbers 1 odds, 2 all. Just do 2 odds because it's on the other page too. Okay, so that's going to get you started here. And once again, I'll post this on the classroom for you so you can take a look at that. I'm going to stop sharing here. And I'm in again. There we go. Okay, so so that wraps it up for today. Did you guys have any questions or anything like that before let me just stop recording?